Welcome, welcome, welcome. Is that working? Yeah, it should be. Welcome, everybody. It would be understatement to say that I'm a little bit surprised to see you here. I hope you don't mind we're wearing jackets. This room is freezing cold. I hope it's getting better with all the heat we have with the discussions tonight.
Hot air up here.
Definitely. One promise front up, you won't see any slides, and this session is going to be better with every single question you are asking. So I'm your host, I'm Markus Eisele, and
My lab is having some trouble here. I'm going to turn it off.
Sounds better. And I would like to introduce our panelists today to you. From your right to my left, that is Santiago Pericasgeertsen. I had to read that just to not mess it up. So we had Graeme Rocher for Grails, James Ward for Play, and Mr. Famous Ed Burns for JSF. I just thought I don't want to see any slides up here today. We just want to talk about everything that is important. And a good idea was to start with kind of a, let's say elevator speech. And on top of that, a few more minutes for everybody. That should make 5 minutes for everybody to introduce the most important stuff they had to say about their beloved babies to you. So let's start, Santiago, if you're ready.
Sure. Is this on?
Should be.
Okay. So I'm Santiago Pericasgeertsen. I'm from Oracle. If you were at the keynote yesterday, you may have seen a demo called Angry Bits. So this is part of something that we call Project Avatar, something we've been working for the last, well, at least I have been working for the last 8 months or so. It's not a project that we have out there, so I guess that's an advantage and a disadvantage today. I'll give you a quick introduction of what Avatar is today and where it's going. Basically, we are very interested in everything that has to do with HTML5 for ways of enhancing the Java EE platform. So we're taking certain bits and pieces from the Avatar platform and turning that into a standard. You may have seen that WebSockets and other things are slowly going into the platform. We're also exploring sort of the view part or the client part of the equation with Avatar. And so that's sort of the other piece that I'm going to be showing at a session on Thursday, I believe, around noon time. So basically, Avatar is what we call an end-to-end framework, web framework. So you can define not only the view components, but also the services in Avatar. But of course, you can also define them using just Java EE without Avatar at all. So you can basically pick and choose what pieces you wanna use. The other thing about Avatar is that it follows the so-called thin server architecture. We're basically pushing more processing into the client. So there's different definitions of a thin server architecture. The one I like the most is the one that talks about where the merging of the view and the model takes place. So in the case of a thin server architecture, we're pushing that process, the sort of the marriage between the view and the model to the client. So we do that at the client rather than at the server. And then the models essentially talk to services, and that's where the data is coming from. But the UI itself is essentially, for many applications, the UI is downloaded only once. And after that, basically the client takes over and talks to the various services to pull the data. Now, because this is HTML5, we don't have just one kind of service. In fact, we have 3 kinds of services in Avatar. We have REST services, obviously. And again, the other side could be either JAX-RS if you're using Java EE, or you can use an Avatar service, which is also which differs from JAX-RS in that it's written in JavaScript as well. And then you have server-side events, support for server-side events, and WebSockets. So those are the 3 types of services that we provide. And for each of those services, we have what we call a different kind of model, client-side model. Again, if you were at the keynote, we talked about socket model, push model and rest model. And if I had more time, I'd go into more details, but that's basically the area that we're exploring at the moment.
1.5 minutes.
I'm done.
Okay, perfect. Thanks. Next one.
Okay, thanks a lot. My name is Graeme Rocher. As I said before, I work at SpringSource VMware, and on Grails Framework, so I'm the project lead there. So Grails is, again, it's a full stack framework. So designed to solve every part of the puzzle. So whilst some frameworks are just focused on, for example, the view or just focused on persistence, Grails really aims to deliver all of the layers of the application, right from the build system all the way through to persistence end to end. It has some pretty compelling features, particularly on the persistence side. There is a technology called GORM, which at its root was originally founded on kind of SQL backends. So you define domain classes, which are your models, and then you automatically get all of the persistence methods. And we can do this because Grails is built on the Groovy language. So, for example, you can do things like book.findByTitle or book.list, and those methods are just there automatically. You don't need to write them yourself. Recently, we've extended the technology further, so it now works with MongoDB, it now works with Neo4j, it now works with a variety of other alternative NoSQL data stores. Which brings me on to another major big advantage of Grails is that it is a plugin system. It has a plugin system at its core and a flourishing plugin community. We have approaching 900 different plugins for Grails. So the core is kept pretty small, but there is a lot of innovation happening in the plugin community. So if you want to add features like to deal with WebSockets, you want to add features to integrate with NoSQL, you want to add features to do web services, you just install the relevant plugin and go. The plugin system in Grails is completely open. It's plugins. You can add some pretty interesting features to your application, from generating RSS feeds, from adding search capabilities through Compass or Elasticsearch. There's really endless possibilities that can be achieved through the plugin system, and it's another interesting component of Grails. And of course, the other interesting component of Grails, which I mentioned before, is the fact that it's built on the Groovy language. So we really designed Grails to be a dynamic language platform. So you get all the benefits of dynamic languages. For example, if folks who are familiar with Ruby on Rails, or familiar with Python, comfortable in those environments, you can be hyper-productive, but still gain all the benefits of the Java EE platform and Java and so on. In terms of the way you scale applications is identical with Grails or regular Java applications. Grails is also built on Spring, which is another advantage itself. You've got all the ecosystem around Spring underlying the Grails framework and all the components that come with that. So it's robust, it's dynamic, and our users love it. We have a growing community and a lot of innovation happening around Grails at the moment.
1 more minute if you'd like to.
No, I'm good.
No, actually not. Oh, very brave. James, your 5 minutes.
Okay. Hi, I'm James Ward from Heroku. How many people here have used Play before? Okay, keep your hand up if you had an enjoyable experience. Awesome. Okay, good. Good to hear. Okay, so I'm actually a Play user, not a Play developer. But I've been using Play for about a year and really enjoying the experience. I think for me, Play Framework is really about 4 major themes. Play Framework has just been rewritten, Play 2, and even Play 1 before that hasn't been around for a very long time. So when I look at Play Framework, what I see is that they really tried to capture 4 different trends that were happening in how we build web applications and then make a framework that catered to those things. So the first one is asynchronous. A lot of our web applications now are starting to use real-time push through WebSockets and Comet and that sort of thing. And so that's just becoming a common way that we have web applications. Everything is not request response anymore. We want to be able to do things that use WebSockets to do real-time push, or be able to do long polling that doesn't consume a lot of resources on the server. And then the second one is client-server. So with client-server, we're really moving back to the client-server model, just now doing that in a web browser without having to install plugins, just through JavaScript on the client, and then talking to RESTful stateless services on the back end. And I think that's really beginning to be the predominant architecture for how many of us are building these next generation web applications, is this client side actually running on the client, and then the server side as RESTful services. And then the third one is being able to scale horizontally. So this requires a stateless web framework, or is done best with the stateless web framework. And so we can just add new nodes and scale out horizontally when we need to handle more requests. And then the fourth one, the last one, is that mobile applications have really caused us to think differently about how we build and deliver our software. There's a few different ways that this is changing things. I think that the primary way is that we begin to think first about the APIs that we build and expose, and then we think about the different interfaces that we'll build on top of those APIs. So, for instance, if we're building a PhoneGap mobile application or a native iOS application that needs to talk to some back-end services, we'll build out those services first, and even can build those out kind of disconnected from the people who are implementing a client side to those services. And then those services could, of course, also be consumed through third parties. So those are the four major trends that I kind of saw happening, and the reasons why I've adopted Play is that it fits really well with those. So to kind of dive a little bit further underneath the surface and go into those four things. So first, the async. Play is built not actually on the servlet API, it's built on Java NIO, which is a library in Java that allows us to not have that thread per connection limit that is typical in servlet-based applications. So what that does is it makes it so that if we're not actively using a connection, we can actually take the thread that was allocated for that connection away and allocate it to somebody else, and then give the thread back when we want to retransmit data. So that works really well with WebSockets and asynchronous requests and that sort of thing. And then that's actually powered by Netty underneath the covers. If you look at like any modern web framework in Scala or Java, they're almost all building on top of Netty. It's really great for doing high performance and really utilizing threads and CPUs more efficiently. Then to accomplish the client-server stuff and how Play assists me with that, this is the second one. Play 2 has an asset compiler. So I'm beginning to write my client side in a lot more JavaScript and CoffeeScript and less for CSS. And so doing that, I could just kind of go into the Wild West and just write it all by hand and not really have any support, compile errors and those sorts of things. But Play Framework's asset compiler will actually tell me when there's a error in my CoffeeScript or JavaScript or my less. It'll compile and auto-minify those assets as well. Then the third one, horizontal scalability. As I mentioned, Play is a stateless web framework. So just out of the box, you really don't have any way to screw that up. If there's no like session place where you can shove stuff, so that forces you, if you do need session state across requests, then you do have to use some external data store like Memcache or a database, NoSQL database, that sort of thing. It also, Play is HTTP friendly. Oh. Wow, that went fast. We'll come back to the rest of those.
Markus is not friendly.
All right. Hi, my name is Ed Burns, and I'm talking about JSF. JSF simplifies building the UIs for Java server applications, and it is the UI standard for Java EE. It's been around a while. It's a platform for others to create arbitrarily awesome components and make money from them. We have a lot of people that have been doing that, consulting services and companies that are built on making UI components and having fun and feeding families, their own and others. It's a global community of developers who are creating value for their clients and sharing code. And it's a great way to mash up stuff at the UI tier. The previous talk that was right here was showing how you could take JavaFX and mash it up with JSF. Hazem Saleh from the Apache Software Foundation and he and I gave a talk at JavaOne a couple years ago about mashups for JSF. And in that talk, we were able to just in the session, build an app that would let you take Twitter feeds and mash them up with Google Maps and see who was tweeting what from where. And you could put Zillow information in there and see what houses were worth, and you could just mash things up together. And when you have all of this integration happening at the UI tier, you need to have state. So JSF is mostly stateful, although you can do a lot of tricks to reduce the amount of state by marking your components as stateless as you need to go. But it's built on components, UI components, and client device independence, which makes it very suitable for mobile devices. Several of the component libraries that are out there right now support a desktop mode and a client, mobile client mode based on the footprint size of the screen, basically. So that's all I want to say. Let's get to the discussion.
Oh, that's easy. Thank you all. That was the first round. I tried to stop my timer so I don't get timed anyway. That was shorter and faster and more entertaining than I expected myself, so thanks a lot for the first round, guys. I had the pleasure to take some notes and have some questions ready, but I would just like to open that up as early as possible. So if you have any questions you would like to fire up at one of our panelists or even a more general one, just raise your hands and I'll try to pick you up. So anybody around? Yeah, let's go.
It depends.
Right.
Tell us more.
So my answer to that is try them all. And do little spikes with a bunch of different ones and see which one fits best with your use cases. Because honestly, I think every web framework is kind of created for a specific type of problems. And so your types of problems may fit best with any one of these. And so I think it's, I could come up here and say, choose play, but I don't think it's good for everything.
No, and I'll say the same thing for JSF. It's, every framework has its sweet spot, every technology does. But it's also important to take a look at what kind of developers you have in-house. You have, what skills do they have? If they're comfortable working with pages and tags and stuff, then, JSF is their bag. But if they'd rather work with, client stuff and really keep out of the server as much as possible, they're really happy with doing HTML5 and jQuery and such that, JSF might not be the right thing, but there's others that up here that could do it.
I think there's some websites that actually have gone through the trouble of taking one problem and writing the solution in all the frameworks. I think that's a good starting point.
Unfortunately, though, a lot of those haven't been updated, and I know this personally because some of them were written based on JSF 1.2, and we added so much new stuff in 2.0, and they haven't updated them, but yet they still get lots of Google hits. So people go and what's JSF? Well, okay, this site says it sucks. Well, that was written in 2008, and we've had some major features since then. So you have to be aware of, when you look at those sites, what versions of the thing they're showing about. Maybe so. Yeah. Well, obviously, when they were written in 2008, the person who wrote them thought they were true, so sure.
Question answered, I guess. Next one, please.
Mm-hmm. I myself am one of them.
You want everybody to answer that, right? Yeah. Let's start with Avatar. I'm so curious about that stuff.
Well, I'm trying to understand the question. So when you talk about all the graphic stuff, you're talking about images, you're talking about CSS. What do you have in mind?
Yeah, well, so like, you have a graphic strategy,
Mm-hmm.
Maybe they want to do HTML5 and have a little bit of JavaScript and make it look sexy, but they don't want to. They're not good at defining APIs and stuff like that. Do you have a UI developer that is smart enough to do programming too, or do you just have a UI developer do graphics and build a programming team? It's kind of a process issue that we run into that you get a really good UI guy, they hand it over, and they go implement it, and depending on the framework, you may have to do a lot of work to convert the mock-ups over to code, or some of them do templating.
Yeah, I think our approach has been that there's probably two teams. There's the designers and there's the programmers. And we try to make it as easy as possible to transition from one to the other. But I guess since we are not out there and people haven't tried us yet, it's hard for me to describe exactly how to do it. So I'm going to let some of my colleagues to answer that question better.
Okay, so well, on the Grails side, it's kind of one of the more sweet spots for Grails in terms of the fact that it's really designed. We have a server page technology called GSP, and it's kind of like JSP, but simpler and easier to use, with Groovy as the expression language. And we have defined directories for your assets, JavaScript or CSS and so on. And because we have conventions, it's always the same across every project. So it's quite common for the UI team to be working on the GSP pages because it's just markup HTML and so on with their normal job. And as long as you point to UI guy, okay, this is where your JS files are, this is where your CS files are, this is where the images go, and this is where the pages are. They're quite happy to tweak it, and we have many users, big clients who are structuring their teams in that way with the UI team quite happily working with GSP and the backend being held by the programmer.
For Play Framework, I think it's pretty similar to a lot of these others. You can go two different ways. One is that you can go with a server-side templating approach, where you're writing server-side templates, and this is where you want to have some interaction between the designer, where you're writing actually code in HTML that gets compiled on the server. So in Play Framework, it's Scala, or there's also a Groovy module or Scalate module that you can use to do the server-side templating. So that's one approach. The other approach, which I think is becoming more common, which people are gravitating towards because it solves this problem better, is when you actually have a strict separation through JSON, RESTful JSON APIs between the client and the server. Then you can totally give the whole client side and the whole UI over to a team that specializes in just web UI and writing JavaScript and using jQuery and CSS libraries and all the browser hacks and all that kind of stuff. And then the backend team can just expose a JSON API and then focus on persistence and on scalability and those sorts of things. So I think that's the better way to address this. If design fidelity is a very important value in what you're building, if design fidelity is not that important because you're building some boring business intranet application, then server-side templating may be good. Also, if you need search engine indexing, then server-side templating is the only way you can really get that.
And I have a question on that. So, but that client team that is going to work, that can be just designers, right? Because somebody has to write all the JavaScript that you just talked about.
Designers,
UI guys normally have JavaScript.
Yeah. So I think it's pretty common now to see teams of people where the web team actually can write really good JavaScript and CSS and also do really good design. Mm-hmm. And if you look around at like GitHub.com, like their site looks amazing, and it's because they have developers who, I guess we call them more diviners is the word we used to use for them. People who have the design sense, but also can write hardcore JavaScript and use jQuery. And so I think we're seeing that role expand where a lot more developers or a lot more designers, people with crossover skills, are doing both sides of the picture.
And just to be clear as well, that approach is also becoming popular with Grails as well. We have a plugin ecosystem, so GSP is just one of the few technologies available for Grails. But we have folks who are using like Handlebars or Mustache to write their templates, and then they're serving up REST, and then using JavaScript to compile the Mustache or Handlebars templates and rendering them on the client. Yeah. That approach is gaining popularity as well.
Well, JSF has been designed from day one to have separation of roles. So, you can do the same thing where you can have your page designer develop the tags. Develop the pages in a web browser. And we know that the people who are good at developing UIs might not have the same skill set as those that are good at developing transactional applications. So we have to recognize that from the beginning, and we have. There's also a JSF Dreamweaver plugin that people like to use. So you can just your pages and do the real Dreamweaver thing, and it will generate JSF stuff for you on the back end. Oh, yeah, we're kind of trying to share here. So we do recognize that there are different roles, and that's something that we've had from day one. There's some new features we're having in JSF 2.2 where you can really have very pure HTML and just put some JSF attributes on your components, and then because JSF does its action on the server side, right? It's all about validating, converting data, using the EL to bind to the model, and then that's where you integrate with your persistence and your CDI and such of those sorts of things. And if you can have only that little bit be brought in by putting a single attribute on arbitrarily complex HTML, because really when it comes down to it, the browser is just sending a name-value pair across the TCP socket. And what we do with that is really what matters on the server side. So look for that as a new feature in 2.2.
I just want to point out something as well, in case it wasn't obvious for anybody, is that the JSF is kind of different to, I don't want to speak for you, but JSF is kind of different to Play and Grails, in that, just as an example, Grails has a JSF plugin. JSF is like a view technology, fundamentally.
Certainly.
So Grails can actually serve JSF pages if you want to use JSF and Grails. It's like, that's why Grails and JSF being and Play being in the same context, it's kind of weird talking about them being competitive when you can use JSF and Grails together and have Grails serve the JSF pages.
Right.
Because Grails is like a full stack thing with persistence and everything all in all. That's kind of like talking about.
Well, it's like JavaOne.
Yeah, exactly. It's kind of like talking about JSF and JPA and this and that all together.
Right. Well, people say, should I use JSP or JSF?
Right.
And then I'll say, well, actually, before there was facelets, JSP was all you could use with JSF. So, and then you could also write any of your JSF stuff in Groovy, because it's easy to do that on the server side too. So it's all mashable.
Yeah.
Let's go. Any further questions? Yeah.
I thought things were supposed to be backward compatible.
What?
I thought things were supposed to be backward compatible.
Well, it's back. Here's the upgrade story. Where you get incompatibility. Where you get incompatibility is if you use JSP in your JSF application, and you happen to have custom tag handlers that are doing non-UI stuff. So if you have programming logic, business logic in your JSP custom tag handlers using scriptlets, this is one of the things we solved with facelets, because facelets does not have any concept of scriptlet at all. So you simply can't put business logic in your view tier. It's not possible to do that. But if you were putting procedural logic in your JSP tag handlers, that would be a challenge, because then you'd have to have, by moving to 2.0, you'd be forced to find the right place to put that kind of stuff. So that might be one challenge. But generally, the upgrade path is pretty simple. If you were following conventions along the way of having your JSP tag handlers really be just there for the purpose of wiring up the UI components, which is all Facelets does with them, then there's a one-to-one mapping of new to old, or old to new, rather.
Yeah, let's go.
In a similar way of having one JSF and Grails, is JRuby on Rails and just using one part of that and stack, is that being considered, or
To whom goes that question? To whom goes that question?
Well, we don't have a JRuby on Rails person up here. That's why it's probably working that.
Yeah, you should ask somebody.
No,
that's
a good question.
One thing to look into if you want to do alternative languages on the JVM is Vertex. It's a new NIO-based server, and it's really phenomenal. But it supports JRuby, it supports JavaScript, it supports I think Scala's coming, Java of course is there. So it's really interesting. It supports async really well in this new kind of style of web application. So check out Vertex.
And it's a VMware project.
Yep, sponsored by VMware.
Oh, and also if you're, to make another VMware plug,
I'm not sure.
I don't mind doing that because it's good stuff. It's the Rue project, and that was something that was kind of really inspired by the Rails way of doing things. And there's Grails for Rue, right? Or you can
No.
No, okay. I thought they did. Well, because they have GWT for Rue and they have JSF for Rue. So
Yeah, they have Rue add-ons. Yeah.
that's what I mean. Yeah. And
Hey
there's
guys,
add-ons for
I'm
Rue.
still holding a Superman question here, so please let's go.
I would like to move discussion from the UI perspective to more developers
Uh-huh.
how, for example, each of your framework supports that I think crucial feature as a contributor developer.
So on the Grails side, first of all, being based on a dynamic language, that just makes your test-driven development experience orders of magnitude more simple. Because anybody who's done test-driven development with a statically typed language knows that you often have to jump through several hoops to make something testable. Usually the static types are always getting in the way. With a dynamic language, you have far more liberty to make things, to swap out to your collaborators, and it's just far easier to test a dynamic language than it is a statically typed language. So in that context, there's also a lot of innovation happening in testing. So has anybody ever heard of something called Spock? Spock? Okay, if you haven't. Even if you're not using Groovy in your production applications, check out using Groovy and Spock, the Spock framework, to write your tests, because you can test your Java code with Groovy code. It's not a problem, and you can write way more expressive tests. And Spock is really a phenomenal testing framework. It's kind of like JUnit, except it's far more expressive. It has a DSL for expressing your expectations and so on and so forth. But really, in the Groovy space, there's a lot of testing innovation and a real deep culture of test-driven development, and we have a full kind of API for our testing framework, which is pretty comprehensive.
So for me, I always thought test-driven development was a good idea, but I never actually did it. Because it always kind of felt like it was getting in the way, right? Like actually writing and running my test was...
Because you use a statically typed language.
Probably, right? So, but with Play Framework is the first time I've actually done test-driven development, and the reason for it is that they've integrated testing so well into Play Framework 2, it actually is assisting me and helping me write code faster to do TDD, which I think was the idea, and it like Graeme said, it never really worked out with statically compiled languages until Play 2. So I've really enjoyed it. What I do when I do Play 2 development is I have one terminal running the Play HTTP server, and then one running the Play tests. And whenever I make a change to a file and save the changes, it automatically compiles, and so I can test in the browser if I need to do a manual test, or the test runner will automatically rerun the test. So it creates a really productive environment for me when I'm doing Play development.
Yeah, so for JSF, JBoss has a nice project called Faces Tester, and that's a good solution. And the standard solutions of Selenium, because doing test-driven development with UI design is a bit of a challenge. But when you try to, if you're following proper separation of concerns, then your POJOs, you can unit test them with whatever other unit testing thing you're doing. That has nothing to do with JSF. So the question kind of, I'm limiting it to doing unit testing specifically on JSF artifacts, and there are some ways to do that with the JBoss project.
So for us, it's been first of all, I should say that we're basically all JavaScript based, so it falls into the category of dynamically typed languages for Avatar, and we're using a combination of Selenium mostly at this point for the very basic testing that we have going.
And a shameless plug for the Red Hat guys with their Achillean project. So whoever is trying to get hands on JSF tests, try that stuff. Any further questions? Come on, I have some fancy ones, yeah?
Actually, that's a good question. I don't know if you probably noticed some of the widgets we were showing at the demo, at the keynote. Those were actually Dojo. So Avatar has a pluggable framework for widgets. We didn't actually develop our own widgets. So we can plug 2 or 3 different frameworks that we can play with. The main one that we're using is Dojo. We're also using jQuery UI and jQuery Mobile. So basically, you can have the same application, and you can just change one bit in the application in the properties file and have it compiled with another widget set. Of course, that's in theory. In practice, things are a little bit more interesting than that. I mean, that's true provided you use the common subset of the widgets that are supported by those. But that's the goal. The goal is to have a pluggable widget set.
Yeah, JSF has had decent tooling for a good long time now, so I'm really happy with the state of things. All the IDEs have pretty good JSF support. Code completion, alt-click to traverse through your different EL expressions, all of that is standard. Refactoring,
Which IDE are you using?
I use NetBeans, but I've seen it in all of them, Eclipse, IntelliJ.
Okay.
Play Framework has great support for VI, my favorite IDE. Sorry to the Emacs lovers out there. It has, I would say Play Framework has decent support in the IDE. You can do the typical debugging stuff, but when you get into like the server-side templating code, there's not much support there. The IntelliJ folks have started working on some Play 2 support, but definitely not as mature as some of the other web framework tooling.
So on the Grails side, Grails has been around a little longer than Play, and the tooling has really matured over the last couple of years. So you've got the Groovy Grails tool suite, or STS, within the Eclipse space, which provides an Eclipse, Groovy Eclipse, which is an open source project for editing Groovy code. And then there's the Grails tooling around the Groovy and Grails tool suite in Eclipse, which allows you to get a nice project. You will run commands, debug, and so on and so forth. And that's really quite coming along nicely. And then the IntelliJ guys have done also a phenomenal job. The Groovy tooling in IntelliJ is very mature now. They even write parts of IntelliJ itself in Groovy nowadays. So and again the Grails support as well is very mature in IntelliJ. And there is also a Groovy Grails plugin for NetBeans, I believe, as well as of course things like TextMate bundles, etc.
And in the case for Avatar, we have a couple of ongoing projects for Eclipse and NetBeans, mostly around helping you get started, create the application structure and things like that, and also for this highlighting, syntax completion, and things of that nature. We don't yet have a UI designer for that.
Another Superman question. Yeah, come up.
Yeah, sure. So Play Framework is containerless, and it manages the whole recompile cycle internally. So there isn't the steps of compiling, rebuilding a WAR file, deploying a WAR file, restarting Tomcat. That all goes away with Play. You just start up your HTTP server, optionally start up your test runner, and then you just go make changes to your files, and Play is internally recompiling everything. So that the iterations when you're using Play Framework get a lot shorter, because by the time you've gotten to your browser window to click refresh or to see your test run, it's already actually recompiled and rerun the test if you're doing that. So it's really productive. Grails is very similar in that way too.
Yeah, Grails is the same. We have automatic reloading built into the framework. It's based on a JVM agent, so it attaches to the JVM, and it'll actually reload changes to even Java code. It's not limited to Groovy. It'll watch all your changes to any bytecode that your application generates, whether it be from Java or Groovy, or even we have a Scala plugin as well. So it'll reload that, and it'll be without restarting the server.
So for JSF, if you make changes to the markup pages, those don't need to be, there's no redeploy on that. If you deploy the app, either exploded or your IDE deploys it exploded for you, any changes you make to the markup pages are automatically there the next time. If you need to make changes to the model tier, you have a couple options. You can use a product like JRebel, and that lets you make any change you want anywhere, and it will not have a redeploy. Or you could use, you could write your model objects in Groovy, and then they would be automatically changeable.
I believe there are even some server options out there that let you use hot swap stuff.
Right. You can configure your IDE with Eclipse to continuously recompile stuff. So there's ways to do it.
So in the case of Avatar, it's similar to JSF. We run on Java EE. We use an exploded directory structure. We don't have Java code in the models. It's all JavaScript, so it's all hot swappable in that sense. You make any change to the source, you reload your app, and it's there.
I just want to check I'm not losing anybody here.
Yeah. This side of the room has been incredibly
quiet.
I mean, come on.
You awake? Hello. We're still here, and oh yeah, John, come on.
Yeah.
Yeah, give it a shot.
Who's smacking who? Yeah.
Yeah, come on. We're waiting for your question. Yeah, go ahead.
So with all these dynamically typed languages, I'm really concerned about performance.
Well, here you go. We have to. This is all about the sweet spot, right? So, what are dynamically typed languages great for, and what are they not great for? Well, they're great for slinging some code out and getting things done fast. It's like working with clay. You're able to model things together and put stuff together really quickly, and then once you have your design a little more solidified, then you could, on an artifact by artifact basis, kind of solidify it some more by converting it from Groovy into Java. And because dynamically typed languages are not as good when you have a maintenance programmer who comes in who doesn't know the guy who wrote the thing initially, a guy or girl that wrote the thing initially, and there's no IDE to sort of help you understand what this thing is except to run it. So I think that's where strongly typed languages come in. They can really help the maintenance programmer.
So I would disagree with that sentiment.
That took roughly 30 minutes.
So on the maintenance side, I don't agree that dynamically typed languages are more difficult to maintain. I think there are circumstances when that can happen.
Yeah, you can write bad code in any language.
And those circumstances are typically when there's dynamically typed code being written without tests. If the company has a testing culture in place, which you should have if you're adopting a dynamically typed language, otherwise don't bother. If you have a testing culture in place, then it's and especially particularly with testing tools like Spark and so on, they pretty much self-documenting in terms of the behavior of the application and really understanding what the application is doing, making maintenance a heck of a lot easier. Maintenance becomes tricky in a dynamically typed language when you see all this, when the code becomes spaghetti and there's nothing verifying how it behaves or how it works or what it's supposed to do. That's when it becomes hard to maintain a dynamically typed language. In terms of performance, on the Grails side, Grails is based on Groovy, obviously, but there are various performance benchmarks demonstrating that even though that Grails is based on this terribly slow Groovy stuff, it way outperforms things like JSF. That's partly because it's stateless, but default by stateless, and JSF consumes, as you increase the number of threads, consumes memory, and things start to slow down. But also because fundamentally, Groovy, the JVM has incredible capacity to optimize Groovy code and inline Groovy code, and Groovy has call-side caching, and it gets really fast. And really, the bottlenecks to your application are going to become your database connections, your REST service calls, whatever you're doing on the back end that involves I/O, way, 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 way before any kind of Groovy code becomes a problem. And even if it does become a problem, some piece of Groovy code, you can, as stated, rewrite that bit in Java quite easily. And you can also, as of Groovy 2, which is in Grails 2.2, or at least cannot one, just mark a particular method as being statically compiled now. In which case, it becomes Java-level performance, that method automatically, just with one annotation. So it's really not an issue, fundamentally, performance. And I know this as well because we have folks like Sky, Broadcasting, who are the largest satellite broadcaster in the UK. They have all their sites written in Grails in the UK, and they're serving 200 million requests per month. No problem.
Want to add something from the avatar blue
sure.
man side?
So I think we need to separate the client versus the server in the case of Avatar. On the client, we are JavaScript. I mean, pretty much that's the only thing you can do, right? I mean, we tried Java on the client. It kind of didn't work. So we're not going to go back there now. On the server side, on Avatar, you have a couple of options. You can use traditional Java EE for your services. So it's Java, JAX-RS. We use that a lot with Avatar. And if you decide to go the JavaScript route, we're running on the NASCON engine. Maybe you heard about that engine. It's going to be in Java SE8, and it has an amazing amount of optimization for the JVM, so it's actually very fast.
Perfect. Thank you a lot. You made my job a breeze tonight. I guess due to the time constraints today, we take a cut here. It was my pleasure moderating it. Thanks a lot to our panelists. I hope you had a lot of fun, so enjoy yourself. Have a great evening.